We're going to look at the basics of perspective now and just go through how you set up perspective, then how you use height lines, and then eventually on perspective or the spectator will change what the view actually looks like. So we can see how this view now has changed from the original drawing to this new drawing here. Now what we have here is spectator, again picture plane, and just the basics here showing how this is all being produced. So this here is what we're looking at. Now the line at the bottom here is called the ground line. So the ground line is where we start our perspective from. So a lot of the time the front edge of the object is placed on the ground line and the picture plane is positioned up against the object here. So this front edge them is bring these lines back here. So again, we don't know where this stops here or this stops here. All we know is the height of it. So the next issue we have to do is extend our vision lines from the spectator to the object. So this will give us a point here. It will also give us a point. So if we take this point here, bring it down to our view here, this gives us a point here. So we now have the baseline of our object. Now we join this point here to the spectator. Again, gives us a point here. So this point here is brought down. This gives us the front of the object. Now the next thing we're drawing here is a line up here. Now we're not going to look at how we get the height of this in this issue here yet. So basically what it is, to find the rest of the points here, we join to the spectator, and that's how the drawing is produced. So all these blue lines here are really important in regarding to bring them down to the plan. Now this is it produced down here, so as it would be appear on your sheet of paper and how it would look. Now this is a very basic question on how you do perspective. So we start off with this object here. So basically we want to do a full perspective of this object here, of this simple object. So the first thing we have to do is find the picture plane. So to find the picture plane, we join the spectator to the external corners of the object. Next we bisect this angle and then draw the picture plane 90 degrees to this bisecting line. And in this case it's going through this front lower right corner. Next we'll set up a ground line. Ground line will always be parallel to the picture plane. Next we'll set up our horizon line, and in this case it's 50 mm above the ground. Next we'll locate our vanishing points. So VP1, so again to find the vanishing point from your spectator parallel to one of the edges, and then to find the second vanishing point we'll go parallel to the opposite edge here. Now this is VP2 found, so you'll see here these three lines here, this is how we find VP1, and if we had other lines going at a different angle we could find a third vanishing point. The next part here is this point here. This here is touching the picture plane, so we can bring this straight down to start our perspective. So what we can see here now is this is what the object looks like. So we're going to set off this height from the ground up. So with a compass we mark off our height. We can join the base back to VP1, can bring the height back to VP1, and again back to VP2. Next we'll find this point here, bring it down to our ground line. Again this point here, which is the spectator, join to the external corner here, bring this down. Next we can start filling it in heavy. So basically we have one side done here, so this side over here is now done. Now we have to see how we deal with the front of it. Now the front of it, we mark a height up here. So we're taking this height, marking it off here, joining this back to VP1. This allows us to bring up this length here. Then this front point here, join to spectator, where it hits the picture plane, bring it down. That gives us our point here. That allows us to draw this piece. And next what we'll end up doing is bringing our lines back to VP2. Now there's a small issue with a piece inside here. So there's a flat piece going all the way around, and there's this block sticking up the front here. So we need to find points in here. So to find them points in here, we just bring this point to the spectator where it hits the picture plane, bring it down, and then we can draw in this piece in heavy to finish off the top piece here. Join these two external points back to both vanishing points. That gives us the top surface here. Then there's one line at the back here to join back to VP1, and if we put this in heavy, this is our dark line in this section here. Now again, for this question, very similar. What we have in this case is 3 steps. So basically, to quickly go through this, to start off again, spectator to external corners, bisect the angle, draw our picture plane 90 degrees to the bisecting line, then set up our ground line, set up our horizon line. This case it's 40 mil above. In this case then we locate our vanishing points. So we've 4 yellow lines highlighted here, so that means from our spectator we go vertical, bring this point down onto our horizon line. That'll find vanishing point 1. Then take 2 lines horizontal from spectator. That'll give us VP2. Next, any edge that's hitting the picture plane, we can bring it down and mark it on our ground line. We can mark a height on that ground line. Then we can join it back to VP2. In this case, we can take this back corner, bring it back down to this edge here. Then each of the steps can be marked off. Now when we have this marked off, we take our second height. So our second height can be got from this front edge as well. So we can join this back, and again, so on and so on. Now this is our full size. Now this is probably the easiest way to set up this one. Draw one side here first, and then what we'll do is we'll end up vanishing everything back to VP1. Then to get the positions, it's basically a matter of joining points from our plan view onto the picture plane by joining them to the spectator. Then it's a matter of just connect up the dots. Now if we go back here, sorry. Now this case here, we're going to do an introduction looking at height lines. In all the previous views we could see where we got heights from the front edge. Now skip through the start of this. So basically the start of this here is we'll start off with the base. So very simple rectangular base, join it back to spectator points and create this base here. Now the issue in this case here is that we have another block placed on top. So we want to locate this block on top, and the only issue is we do not know a height for it. Well, we can see the height here, but we can't mark it off here because it's not touching the picture plane. So to deal with this, we need to have a look at how we introduce height lines. So we have a 3D view of it here. So what we want to look at is how we get a height here. So the first thing we have up here, what we could do is draw a line across here, bring these points to a spectator. What that will give us is this purple line here. So we now know the location of where the base is. And basically we can find the base position here. So we can find the base position here. The only issue with this is we still do not know the height of it. So we have this here. Now this method here then is looking at how we can find a height for this. So to find a height for this, what we're doing is we're taking this edge here, this front edge, marking the height of it. we're going to vanish this back to our vanishing point here, and then on this position here where the purple line has been brought up, we're bringing the height back along here. And basically this is finding our front edge here. Then we can bring these back along here, mark off the top point here. Now that's one method. This here, a slightly more complex question dealing with height lines as well. In this case we have spectator, and in this case here our picture plane does not hit the object, so that means none of this object can be drawn touching the ground line. So in this case here we start off our horizon line and our ground line, we find our vanishing points, the same method, but in this case we need to construct actual height lines. So to construct a height line, the easiest way to construct a height line is to run something into the picture plane. And the easiest way to show you this is, it's drawn up here in the 3D view here, showing this edge of the house ran on straight to get an actual height. So if we look at this in the drawing here, what we're doing here to set up a height line, we're taking this edge, we're running it until it hits the picture plane. So we're extending this edge until it hits the picture plane, then bringing it down onto the ground line, and then what we can now do is we can mark true lengths off this line. Now to mark the true lengths off this line, we can take our two heights, so the height up as far as the eaves of the house and up as far as the ridge of the house, and we can mark that off. So if we look at the drawing here, we can take these two heights, mark it here and mark it here, vanish them back to the vanishing point, and then we have heights now. All we have to do is find the location of the house. So this is where we're joining points now from our spectator and find them on the picture plane. So we have this front edge here found, do the same with the back edge, and then if we take the ridge of the roof, bring it onto our picture plane, bring it down, that allows us to create this drawing here. Next we can vanish all this back to VP1 to get the main section of the house. Now we have another piece of an extension onto the house here that we need to draw. Now again, similar method here. What we're doing here is marking off a height using the same height line in this case, and taking our three heights, and basically the reason we can use the same height line is this height line is used for this edge here, but these three heights are on that edge as well, so we can use the same heights here, vanish it back to VP1. Now it's important that we know which vanishing point to vanish it back. The reason we're vanishing back to VP2 is this green line is parallel to this vanishing point, so that means this is the vanishing point we vanish back to. So we can mark off our heights and finish our perspective. Now if we look at this one here, another example, again what we have in this case here is we have a picture plane that does not touch the object, so we'll have to look at using height lines again. So again, vanishing points all set up the same way. This is our height line now for our base, so we've extended it until it hit the picture plane, brought it onto our ground line, measure our height, mark off our height, vanish it, and then produce this drawing here. Now we're looking at this object here, so we're drawing this purple line. So to find this diamond, we've drawn this purple line, we have a point here showing this front edge here. So what we're going to do here is bring this purple line onto our picture plane and then mark it, bring it back to VP1. Then what we can do is from our spectator locate in this position here. Now this gives us the position for the diamond to start. Next we have to look at joining another point to find this point here. So in this case here, what we can do is bring this purple line here onto the base here in plan, bring it to picture plane, then bring it down, so this gives us this position here. Same on the other side, draw this line, then bring this point here to our spectator and mark it here. Now these 2 points can be drawn in heavy. Next, the back 2 points, similar method again, marking. So this is how we locate it. Now next we have to find a height for this object. We still don't have a height for this object, so we need to see how we're going to set up a height line. Height lines need to go parallel to vanishing points. So this vanishing point here, so what we've done here is extended this green line, so this is our height line, so it's going to be extended parallel to your vanishing point to this location here. This means when we bring it down to this view here, to our perspective view down here, we're going to be joining it back to VP1 because this green line is parallel to this line here, so we'll be joining any heights on this line back to VP1. So if we mark the height now on this line here, so this is our true height, now we can bring it back to VP1 and then extend up our 2 lines here. That gives us our 2 front edges here. Now next thing then is to find the length of these 2 points here in the middle of the object. What we've done in plan here is drew this red line, located this point in the center. That means we can locate this point here, and that gives us ability to find these points in the center. Now another method that we could have done is took another height line from point C here, extend it, then draw our new height line here. Again it's parallel to VP1, so we'll be joining it back to VP1 and then locate the height like that. And that's basically how we use height lines. Now this here's second question on use of height lines. So we can see in this image here the elevation of this, what the actual object looks like. So it's an L block with 2 other bricks inside it. So if I quickly go through the start of this, what's different about this is the picture plane is now cutting through the object. So to find the front of the object here, it's slightly different. Basically our front edge here, we have to bring it back onto the picture plane. So we're joining our front edge here, bringing it back onto the picture plane. So instead of all these points where you locate them here and here, in this case here, to locate this point you still need to bring it onto picture plane. So the difference this time is we're running it up to the picture plane. Now we have 2 points here. We can mark up here heights on them. So we can mark this point here a true height on it because we know the height of this here. What that allows us to do then is bring out from our vanishing point 1, extend out to get the front edge here. So this is how we locate the front edge in this case here. And then we can just draw the base of it, fairly straightforward. The height of this black back object here can be marked off from using a height line. So we've taken the green line here to use this as a height line. Now this will give us a height for this surface and also for this surface because they share a common edge. So we mark off the height. Again, it's parallel to VP1, so it joins back to VP1. So we can draw in the back section of this, can bring this point back to VP1. Next we'll take another height, so we'll mark off our second height on the height line with a compass, vanish it back to VP1. This allows us to get this edge here, and this allows us to draw this section here. Again, to get the final block here, we need to look at how we get a height line for here. So in this case here, we can locate all the bottom points. So we've located all the bottom points. The only thing we do not have is a height for it. So we need one more height line. So the height line, in this case here, we brought it from here, bring it down onto the ground line, then we mark off our height, vanish it back to VP1. That gives us our 2 positions here. That means we can extend out from our vanishing point and finish our perspective. And that's basically using height lines, extending them in the plan onto the picture plane. Now, this question deals with circles and curves. Sometimes in perspective drawing you will need to be able to draw a perspective of curve. Basically it's a matter of finding points on the curve and then matching them in the perspective. So we find the points in plan and then we'll draw them in perspective. So in a lot of cases here we will need to draw a piece of the elevation. So again, starting off with ground line, horizon line, vanishing points, and we'll draw the base of this very quickly here. Now this is the base. Now we need to deal with this circular object here. So we divide it 30-60. We have our points located. We bring our points down to plan. So we have them on the front edge and the back edge. Next we need to locate height lines. So we've got a height here. So in this case here we're going to use this front edge here and this point here as our height line. So that means we can mark all our heights off this front edge here because they can all vanish back to VP2 in this case. And then it's just a matter of find these points, bring them onto the picture plane and mark them down. So if we look at the second height here, so we're marking our second height here, vanish back to VP2, take these 2 points now onto our spectator, then bring them down from picture plane and mark them off this height line. And then the top point is done the same way. And that's our curve drawn in perspective. Now to get the back points in perspective, so we're going to have another curve here. We can take these points here and vanish them back to VP1 and then find them on our picture plane. So take these points at the back here, locate them on our picture plane, bring them down and find them that method without using any height lines. And that's our curve drawn in perspective. Now this is a second curve, but in this case here the base is elliptical this time. So basically again we start off with our plan, spectator, picture plane, ground line, horizon line, and in this case here we're going to set up this imaginary blue box around the object. Mark off our height on that imaginary blue box, and in this case here we're taking slices. So we're taking green lines here and acting as slices. So we're creating all these slices here, and these slices gives us points on the ellipse itself. So what we can do in this case then is take our points, bring them onto this imaginary blue box here, and then mark them, bring them to the picture plane by drawing them to the spectator, and then it's a matter of bringing all these points down and matching them all up around. And that's basically how you create this elliptical piece in plan, but it's drawn in perspective. Now a lot of the time when we're dealing with ellipses and curves there is an awful lot of construction lines. It's not typical that you'd be asked to draw too many curves in perspective because of all the construction. So what we have for this very simple object here, we have an awful lot of construction lines. So we'll just draw this in heavy. And basically the last piece here is just to draw in the top section here. So the top section here, we'll just create this, and this is probably the easiest part of this drawing, just to draw in this top section here. Now this here is slightly more complex question here, dealing with curves here. So if I just quickly run through, but it's the same process as all the other questions. Start off with all the easy parts first. So the base here is a rectangular base, so we start off with that. Then we've got triangular surface then, so that we can set up very easily. Then we look at taking slices in plan here. So these slices in plan here will be points on this curve here. Now by bringing it up to the elevation here, we've got the actual heights. So basically what we'd have to do is, looking at this edge here that's highlighted here, bring this line down to our ground line. So this is our new height line. So our new height line is brought by bringing this parallel to one of the vanishing points. So this is parallel to VP2. So in this case, all the points will need to join back to VP2. So we can mark off our heights here. So we can mark all these heights can be marked off here. And it's a matter of just plotting all these points by joining them to the spectator, then joining them from the picture plane then down to our perspective of the question. And that's how we draw this complex curve here. Now the back section, we've got what looks like a wedge, a triangular wedge. So possibly it's only a matter of bringing a few points here. Again, we can use the same height line. And this here is the perspective. Now there is another method of doing this. Instead of using one height line, we could take all individual height lines for each of these points. So if we look at this point here, brought down here, then mark the height for this one. So this height brought back to VP2 gives us these two heights here. Now these 2 points in plan here, join to spectator, where they hit the picture plane, bring them down, locate these 2 points for you. Now this again, another section here, but I'll just quickly flick through it. Just basically we have sections here, and basically we start off with all the rectangular sections first, and then we look at how we do the curved sections then. So what we have here set up here, a whole series of points here. So basically what we're doing is setting up this imaginary box for the base here, and bringing all these points on this imaginary box to the picture plane. So we're bringing all these points onto the picture plane, and basically plotting out all these points then afterwards by joining everything to spectator point and to the picture plane. That's how we get the front curve. Then back 2 points, back corner is located by joining the external points back to the vanishing points. And then this intersection then is fairly straightforward. Again, have to use a height line in this case here for the back sections here. Now finally what we look at here is, this is an ordinary level question from 2009, basically to a house with a bit of an extension on the side of it here. So again, what we have is point A here, spectator point, and basically we have to start off from scratch setting up our picture plane. So taking our 2 external points and joining it, bisecting the angle, drawing our picture plane. So this is what our picture plane looks. Draw our ground line, horizon line, bring corner A down. So we'll be bringing corner A down. What we're setting up here first of all is the vanishing points. So vanishing points again parallel to the edge. Corner A is brought down here. That's going to be a true height. So we can mark our true height on that line. So we can bring corner A back to VP2, back to VP1, mark off the 25 height, draw in the base of it, mark off the 40 height this time, and again this front edge can act as a height line here for this point here. So we join that back. To find the ridge here, we need to join this ridge back to the spectator, find it on the picture plane. Then we draw the front edge here, vanish it back. This here is the front section. Now to draw the back section, take this point here, bring it to spectator, bring it down here. Now what we've done is we've extended out this front edge here to find its location, and then brought back this point here, this back edge. Now we need to take a height line now for this, because we've no actual height for this. So to take a height line for here, we can take a slice down this way, or we could take a slice down through the center. So in this case here, we'll take a slice down through here to help us. So this green line is our height line brought down. Now we can mark off our height for the eaves of the roof and the ridge of the roof. So we can mark off this height. So this here shown in the 3D graphic over here. So this here, the ridge, then second height marked off. And basically we can just finish this drawing here. Now this here is one section. Now we can join them back to VP1 to find the back sections. So basically we're going to vanish these back to VP1 and then join each of these points then to the spectator. So we can see it drawn here first. Now we're extending these back to VP1, then find them on the picture plane, and that's the question completed. Now there's a window to locate on this drawing, so the window is located here. So it's going to be on this front edge here. So obviously it would have to be marked off in plan here. So on point B here, it's on this wall here. So basically what we do here is mark off the heights, again using our height line. So we have to use this height line, then mark the heights on this front edge here, and what we can do then is vanish it back to VP1. So we can now vanish these back, and basically to find the edges of the window then, find their position in plan, take these 2 points then to the spectator, locating them on the picture plane and bringing them straight down, and that's how we locate the window in plan. And that's the full perspective question finished. These are sample questions now as a follow-on to the introduction to perspective. So basically what we have here is the photograph of a box with a lid. In this case here, the lid is sloping here. So what we're asked to do in this question is, picture plane goes through corner A here. Your spectator is located 90 away from A, so straight down in this case here. And then the horizon line is 45 above the ground line. Scale in this question is scale 1:1. Question 2 here, similar again. The object is slightly different. It's a bus shelter this time. So we have picture plane going through corner A. Again, it's not shown what angle it is, so you'll need to find the angle at which it is. The spectator is due south and it's 90 away from corner A. Horizon line this time is 75 above the ground line. This case here, third question, is draw the given plan. So the given plan is this here, and then locate spectator 90 away from A, draw picture plane touching corner A, and then the horizon line is 100 above the ground line. So what we'll notice here is the overall height of this object is 75. So we'll see the full roof surface here. It's well below the horizon line. Now, the fourth question is an ordinary level question from 2009. So basically what it is here, this house here, so we've looked at this in the video, how to do it. This here is the instructions which you'll be given. So we're drawing the plan in this case here, then drawing the spectator 1440 away from A. It's very important to remember in this case we're dealing with a scale here. So the scale here is scale 1:20. So each measurement needs to be divided by 20. The horizon line in this case here is 1000. So again, divided by 20. Now, there's a window to be located in here, but we've seen how to draw this. You will need to use height lines in this question as well.